Assalamualaikum everyone. So today I'm going to make a new video for us, and this video is cover all the chapter 3 under parallel algorithm design, which is high performance and parallel computing. So this is the notes from Dr. Ismail, because she's the one that the coordinator for this subject. So in this chapter there's a lot of theory, so I hope that you will just stay tuned in this video and try to understand all the theory. So basically what we're going to look into our subtopic here is we're going to look into principles of parallel algorithm design, and then parallel algorithm modes, parallel programming models, this is one model, poster design methodology. And for the poster design methodology there are 4, which is under partition. Later on you will look into what is all the meaning of partition, what is communication, agglomeration, and also mapping. So each from this there is a link for each other. There is a sequence between all of that. So let's move. So we directly go to the principles of parallel algorithm design. So for this parallel principle of algorithm, so in practice is specific having following versions of non-trial parallel algorithm, which is you need to identifying portions of problem that can be performed concurrently if you want to apply the non-trial parallel algorithm. And then you will look into the mapping, and it is used for computations onto multiple processes running in parallel, and then distribute input, output, intermediate data among the processors, managing access to data shared by multiple processors, and lastly synchronizing the processor at various stages of the parallel execution. So as I already mentioned, it's more into theory. So we look into the first one, which is if you look into the outline, first we already touched in the principle of parallel algorithm design. What is the introduction on that? And now you're going to look into parallel algorithm model. So there are 5, I think. Let me check. Yeah, you have basically 5 of all under parallel algorithm models. First is data parallel model, task graphic model, work pool model or task pool model, and then the master slave model, and lastly the pine line model. So you need to remember that under parallel algorithm model there are 5, which is all of these. And for the each of following model that were given under parallel algorithm model, you need to know all the details. So let we look into one by one. For data parallel model, the tasks are statically or semi-statically, which is on the mapping method, onto the processes, and each task performs similar operation. So later on you will look into what is task. So what is operation, what is programming, and etc. So this is all on the computing terms. So I guess that you know already task is like processing from your input, what you give to your machines or computer or also a laptop. So first one that you know under the parallel algorithm model, there are data parallel model, and it is the tasks that are statically or semi-statically. So these first two hint, the first hint for the data parallel model, and another keyword for data parallel model is each task performs similar operation. So when you're given the scenario on certain sentences, let's say you were given on a scenario, please choose the model under your parallel algorithm with the tasks that perform similar operations, and it is statically or semi-statically, so you will know that it is a data parallel model. So next is on task graph model. So task graph model is computation in parallel algorithm. Of course, we still under a parallel algorithm model. So it can be view a task dependency graph. So over here you can see also this is the first hint or the first keyword for task graph model. The task graph is used to map the task into processes. This is another keyword for task graph model. And then the third one is work pool model, or also task pool model. So the task pool model is the work pool or task pool model for the character like this, which is dynamic mapping. So it's of course different from others, of the task into process for the load balancing, in which any tasks are potentially be performed by any processes. So this is the keywords which is into the process for load balancing under your work pool model and task pool model. The fourth one is the master-slave model. In this master-slave or the manager-worker model, one or more master process generate work and allocate it to the worker processor. While the last one is the pipeline model, which is it is stream data passed through the successions of process. So this is the keyword, and another one keyword is each of which perform different tasks on the data. So if you look into the first one, you can see it is perform similar operation, and then the second, which is you map it the task onto the processing, and third one is on the dynamic mapping for your processor under your load balancing. The fourth one is you going to process, generate and allocate to works processor. Lastly, which is on the pipeline model, each of performance is different tasks on the data. So it also called as a stream parallelism. So sometimes you will also were given the scenario which is the data stream is a stream parallelism, so you know that it is under pipeline model. So under this one, under the parallel algorithm model, you will cover all these 5, but after that you move to the parallel programming. So after you look into algorithm, you're going to look into programming model, which is there is a task, this one that I repeat the first, I think in the first slide or second slide, about your task and etc. Where is it? When I explained about the data parallel model, I already mentioned to you that we're going to look into what is task, what is operation, and etc. That's why currently we're going to look into it under the parallel programming model. So on the programming model, first we're going to look into task and channel model, and then the message passing model. Third is data parallelism, and lastly on the shared memory. Still, all of this is theory. You need to know about the things inside all of this parallel programming model and then parallel algorithm model, something like that. So over here, this is the example of task channel model. This is just example. First, over here you can see the arrow represent as a channel, and then all this circle is represent as your task itself. And you have, of course, your CPU or your computer. Over here you have a program, local data, and then input output port. Of course you need it, and then you have import and output. And this is the example of sending instruction. So when you try to send message on channel X, so this is channel, so these channels is represent as the channels X. So let's say this is your message over here or your task, so you're going to flow it to randomly to another point. So you will transmit it using the channel X. So this is just an example. After this we're going to look into deeper. So task and channel model, what is the meaning by task? Task is consists of program or instruction. Let's say you will give instruction for your computer to perform the uninstall application, let's say. So it is on the instruction or the program that you are opening, and then let's say also it is a local memory and collect on input output port. So you can also perform by using let's say you put and install your USB pen drive, which is for your input port. So you give instruction to your computer that you are inserting the USB device. So let's say there is autoplay and etc. So you instruct it to run the program. So this is the one example on task. And then task also having the local memory contain of program instruction and also local data under the local memory. Task sending local data to other tasks through output. So from here, let's say you given the instruction on, let's say, eject your USB. So from your local data, you will transmit to another and to your output port. Or let's say you want to eject your CD-ROM. That's why you will do the task through output. And then a task also receiving external data through your input. This one is quite similar to example in the point 1. Next, on a channel. A channel is a message queue that connect an output of task to an import of another task. So of course you will have a sequence in connecting all your message. In, let's say you want to open some program, you need to have a queue. You cannot simply basically open it straightly all together. So it's just a sending message queue, something like that on the channel, and then receive data appear at the same order as they were placed through output at the sending task. So let's say you try to open multiple application. This is just an example. So you given the message to open, you instruct or your computer to open 2 application, let's say in one time. So you going to have a queue using a channel, but let's say you will instruct it to open it parallelly. That's why you can also have the same order as they are placed through the output of the sending task. So you open it similar and together parallelly. Next is this one is the example of your message when you sending and passing it to others, which is message passing model. Quite similar to the previous picture. There is only different on channel. They are not pointing up here, and also it's not also pointing up on the task. So all of this is the similar task. So you pass it to each other, and you're going to use your channel. This is the channel that represent as the error. Foster parallel algorithm design methodology. As you check on your outline, there are 4, which is I already go through it on the partitioning, communication, aggregations, and lastly mapping. So you need to know each of these method. So first method is under your partitioning. So you will connect it after you having the partition, which is over here. If let's say you having a problem, you will use the first method, which is partitioning. And after you already partition it, you will, let's say, specify which problem, what problem. So you will like grouping them. And after you finish on partitioning, you will send it and do the second method, which is on communicating. So under communicating over here, or communication similar, so you will send to the communicate method. So you will link it to each other. What is the problem? Let's say this is problem A, problem B, problem C. So this is the same problem. Over here having a same problem, but maybe A and B over here, let's say they are linked together to each other. So that's why you need to do the second method on the communication. So you need to link it to each other. And after that, after you already link it, you need to do the third step under your agglomerations. You will grouping it back. So you can see you already do the grouping using the partition method, and then after that you link it, and then you group it back. After that, you will do the last method on mapping. So after you already grouping, after you already done the communication, link it to each other, and you will do the mapping. There will be a link for each group. So you can see that this is link for each group over here. This is the step of methods from 1, 2, 3, 4 if you are under the Foster parallel algorithm. This is the design. So on the partitioning,
It's 23 hours.
on partitioning, it is similar. Let's say the process of dividing the computation task into smaller pieces of tasks. Similar also, same what I had mentioned, you grouping it to similar tasks or a smaller pieces of tasks. A good partitioning split data on and also computation into many primitive tasks. So a good partitioning means that you will having a many group, so you already have many primitive tasks over here. So it's can be said that a good partitioning mean as long as it's not as long as, okay, if let's say you have many group of tasks, it means that it's becoming good on your partitioning, on your partitions method 1. And then for the aiming, what is the purpose or what is the objective of variations is to discover as much parallelism as possible. So you need to know under partitioning, you need to know what is the objective also. So there is only one objective, so it's easy for you to remember, which is you need it want to discover as much parallelism as possible. And then there is two approaches of partitioning. So this is the first method, but under this method there is also another approach. You can have two possibility of approach that you can use. First is data centric approach, another one is computation centered approach. So you can check it for these two approach of partitioning. Now we look into each approach. First on the data center approach. Data center approach, also known as a dominant decomposition. So you can see dominant composition is divided the data into pieces and then determine how to associate computation with the data. So this is the method of the data centric approach, or it also known as domain decomposition. Another one is under computation centric approach, or also too big. Or before we look into it, we look only for this domain decomposition first, then after that we go deeper on the computation centric approach. So over here I give you the example for 1D or one dimension domain decomposition, and also second or 2D domain decomposition. So the third one, you need to try and figure out it, how is it. Later on I will give you the answer, but now let's check on this. You can see this is the example of 1D domain decomposition under the data centric approach. This is how you're going to do the partitioning of your data. Or you can see over here there is a X, Y, Z, and decomposition Y direction and also X direction. And you have two possibility also, A and B, and you need to check how many primitive tasks presented. So you can see there is, let's say over here, red, green, blue, yellow. For each of these you already do the parenting. And if you compare to the 2D domains decomposition, so you can see it's become larger. So there is a tree which is a decomposition in Z and Y direction, and then Z and X, and then XY direction. So how many primitive tasks present for each of these? You can calculate it by your own, and you can see that as mentioned in the partitioning as mentioned in partitioning, you notice that a good partitioning will be split the data and computation into many primitive tasks. So if you compare between 1D with 2D, you will notice that this is much good rather than 1D, because you are having much primitive tasks that you are already grouping it. So this is the one that I mentioned. How about the 3D domain decomposition? You need to figure it out how it look like, and later on I will give you the answer on this also. So under this computation centric approach, you will also notice that it is similar to functional decomposition. So functional decomposition is the complementary strategy that divide the computation into pieces and then determine how associate data with the individual computation. So normally it use that functional decomposition on the collection of tasks that achieve concurrently through pipeline parallelism. So there is 5 method, isn't it? So it is under the pipeline parallelism. You can check back your notes over here. Let me go back first. So there is a 5 model under parallel parallelism, which is first data parallel model, graph model, and then work pools model, the master slave model, and lastly the pipeline model. This model normally are using the methods of your partitioning under your computation centric approach. So normally you are using this under the pipeline model. Go back to the exact slide over here. So next is this one is how the flow for decomposition analogy. So let's see. You were given the example if you have 100 car to be fixed. Then you send it to the input and you have the workshop, which is you will deal all and try to fix all the broken car and etc. And your output will be 100 working car. So you will solve everything under the decomposition method. And another one, this one is you directly, because you have one workshop only, so you directly handle all of these 100 car. But another method under decomposition analogy, the second one, you will split it into 2, which is you have similar 100 car that broken or something breakdown, you need to fix it. Then under the second analogy, you will divide it into half, which is 50 cars for each others under the domain decomposition. And then over here you will like grouping it. For this 50 cars, you will fix the aircon. For the 10 car, fix engine. For 10 cars, fixed wiring for 30 car and so on. But for this one, this is called as the functional decomposition, which is under complementary strategy. So for the another group, maybe you will fix it on 20 car for aircon, and then it's not similar because you're going to separate it to two groups. So maybe you will notice that this group you are having much more technician or specialist on aircon. This group having the technician or specialist in wiring. So you are using the complementary strategy rather than you use the computation analogy one, which is you send it all the 100 cars in one shop without you grouping it into what of the problem for each car. So I think it's better, not think this is the better under the decomposition analog for 2. And decomposition techniques over here, you can see we will discuss on 4, which is recursive decomposition, data decomposition, exploratory decomposition, speculative decomposition. So back to this one, when you look into this under your partitioning, you still in the step number 1. If you look into this under the Poster parallel algorithm, you still under the partition or partitioning step or method. So you not even touch the communication, agglomerations and mapping yet. So under this partitioning, you are having the objective, and then of course you have a method or approaches for this parenting. So you have 2. We already looked into data centric approach, and now we look into computation centric approach. This is where currently we are looking at, and you can see there is 2 approach also, which is under first analogy. First analogy, you send it directly all the problem you are having. Let's say for your computer, you solve all it together without you even grouping it. So the second analogy, you do the complementary strategy, which is you group it into 2, and also followed by what is the problem for each computer or program or whatever, something like that. And we touch now on the decomposition technique. There are 4, which is recursive. I don't want to repeat it again. And for each of these, we're going to look into, and as mentioned, it's all on theory. So hope that if let's say you need break, you just stop for a while and then you will continue it looking at my videos. Okay, under recursive decomposition is a method for inducing concurrence in problem that can be solved using divergence theory, you divert, and also concurrence strategy. So this is under recursive decomposition, which is the example, a problem is solved by first dividing, which is into a set of independent subproblem. So first of all, the keyword for recursive decomposition, sorry, my focus are interrupt because I got message from a group for tomorrow class. Okay, so I continue. Under the recursive decomposition, the keywords is on the example, which is when you have a problem, it is solved by the first dividing, which is you divide it into a set of independent sub-problem. So each of it solved by recursing, apply a similar divisions into smaller sub-problem and etc. So you're going to follow the combination of their result. And the second one under data composition, in this method, the decomposition is done using two steps. For this one, it's just on the first dividing, and you divide in the first and you will solve it directly. But for the data composition, you're going to done it with two steps. The first step, the data will be for the computations are performed in partition, and the second step, the data partition, is used to induce the partitionings of the computation into a task. So you will divide it. Let's say for first you will divide 50 application, and then you will perform it into each problem that it have and facing. After that, for second step, for each problem you will do a parenting or grouping for all each problem. The operation that these tasks perform are different. Data partitions is usually similar. So I think the keyword is there, which is using two steps, and you need to know each of these steps under data compositions. The third one is exploratory decomposition. This technique is used to decompose your problem, not your problem, your computer or your application, etc., whose underlying operation. So the main purpose is to search of the space for the solution. So the search space is partitioning into a smaller part concurrently until the desired solution are found. So let's say you are having the problem, you cannot boot your Ubuntu or you cannot boot your Linux. So you try to find what is the problem, and then you will find the solution until you find the exact solution for the problem, a cure. And lastly, it's for the speculative decomposition. It is used when the program may take one or more many possibility for computations, which is basically depend on the output of another computations. So another example, if in the scenario where one task is performing, the computing which is from the output is used in deciding the next computation, and then other tasks can also concurrently start the computations of the next stage. So you already touched four things or technique under decomposition technique. Next is you still under the positional algorithm, but over here let's do the checklist, which is still under partitioning, and we not yet touch the communication part, which is for the second step. This is still under the first method, so under partitioning. So what is the checklist, which is a number primitive tasks, and also on the minimize the redundant data storage. Primitive task, this one maybe you can try to read it because it's just on the things of the checklist. So directly we're going to look into our second task, which is under your communication. So basically, what is the method for the computation? What are communications doing? Is the data must be transferred between tasks. So it's allowed computations to process or proceed similar. This information flow is specific in the communication phase or parallel algorithm design. So in this communication, you have the several categories that you can divide it in. First categories is local and global. Second is structures and unstructured. Either it is static or dynamic, or lastly, either it is synchronized or unsynchronized communication. So you can categorize for under communications into 4 categories, which is local, global, structure and unstructured, static, dynamic, and also synchronized and unsynchronized. For the local communication, for the local and global, you need to know that local communication is when a task communicate with a small set of other tasks, which is their neighbor only. But when we look into global communication, as we know, global, we already know the meaning of global. So it is task when a task communicate with many other tasks, not only from their neighbors. And under structures and unstructured, for structure, you will notice that it is used the route of task communication form a structured network like a tree or a grid. So you have the structure. But for unstructured communication, the route that you are using for your task communication form an arbitrary network. So this is the keyword for unstructured, and then structure, of course, you're going to use the tree or grid for communication. Another one is under static and dynamic. So under static also is similar also in the global and also local, something also like this. Under static, the identifications of communication partner does not cover over time. But when you touch on dynamic, of course, the communication partner may be determined by the data computing at running time, and maybe it highly in a variable. And lastly, you will look on the categorize between synchronized and unsynchronized. If you are having synchronized communication, procedure and consumer execute in coordination fashion. So over here you can see that the keywords that you process and also consume, the pair of cooperating in the data transfer operation. And for unsynchronized, data may be required that tasks obtain and also transmit data without a cooperation of the task of other tasks. So this is the keyword, without cooperating of the other tasks. And this one you can see is produce and consume pair cooperation from other tasks. So you will you already touch on partitioning and also communication. Still under communication, you will look into issues, and in the communication phase, what will happen on your communication. So there will be issues when you are facing on the second method of postal parallel algorithm, which is the communication between tasks may be considered as part of overhead. So this is very important on your computing purpose. So therefore, minimizing communication overhead is important as one of the consideration while you want to design a parallel algorithm. It's too big. So there is a method, because this is the problem. All problem there will be also a solution. So the solution for this problem under the issues on communications is that method of content interactive overhead. How are you going to do it? It's maximizing data locally. And then how you going to maximizing? You need to minimize your volumes of shared data, and also minimize the frequency of your interactions among the tasks. And then minimizing also the on the content and also contentions of your data, and replicating data or computations. So this is the method how you're going to solve the problem under your communication phase. Is it okay? I think I want to make it smaller. The communication operation are balanced among tasks. So each task communication will only a small number of neighbors, and then tasks can be performed their communication concurrently, and tasks can perform their computation concurrently. This is under your poster design method for the checklist. Similar on the partitioning, you also have the checklist. You can look into it. And now you already have finished your second method. Now you look the third method, which is agglomerations. So under agglomerations, you will look similar also in both a method previously. So let's check one by one. So agglomerations over here, you can see it is basically a process of you grouping the tasks into larger tasks in order for you to improve the performance, or you also want to simplify your programming or your task or your application. So this is the objective. So each of step or the method under poster algorithm, you need to know that each of them having the objective or the aim. So the goal is to lower the communication overhead, and then maintain scalability, and also reduce on the software engineering costs. So it is simple over here. You have the checklist, which is there is 4 that has increased the locality for the parallel algorithm. The second one is a replicate computation, which is take less time than the communication they replace. The amount of replicates data is small enough to allow the algorithm to scale. And lastly, task has the similar computation and communication costs. And still under the checklist, you can also try to read it. And we are currently at the last method under the poster algorithm method. A model, sorry, not method, poster algorithm model. So over here you have the methods number 4, which is under mapping. For mapping is the process of assigning tasks to processor. So what is the objective? To maximize the processor utilizations and maximize and then to minimize inter-processor communication. So this is the goal for mapping. And processor utilization, the average percentage of time system process are actively executing tasks necessary for solution. And lastly, the processor utilized is maximized when computing is balanced evenly. So lastly, there is another one is covered under mapping, inter-processor communication, which is the wait. I want to connect my charger first. Suddenly after it's come out to 10, then it will basically turn off without noticing me. Plug in my PowerPoint. Okay. Now I didn't have my mouse connected. This is the problem using Mac. There is no enough USB port, and it is using the C type. Make it harder for me also. So go back to our slide, the poster design method and the mapping. So you also notice that it is for the inter-processor communication. What we look into, which is when there is two tasks connected by channel are mapping to the same processor. So under mapping, you will see also on the design example on mapping. You can read by your own on the mapping, what is basically the detail on that. And this is the example. Assume that equal processor speed for each, and then equal computations by each task. So each task you can see A, B, C, D until H. So each task having the equal processor speed, equal computations, and also equal processor communication delay. So map these tasks into a parallel computer with 3 processors. How are you going to do it? So this is a mapping example. Can you try to figure out how you're going to mapping it using a 3 processor into parallel computing? So this one is you try to map it. So because it require for you to have 3 processor, you represent it as P1, P2, and P3. If each task require P second to complete, what is utilization period of P1, P2, P3? What is the ideal periods of P1, P2, P3? So this is a possibility question that can come up in the mapping. So you can mapping it using this step, or this one is just an example. So you can see that it's mapping it like P1 you have task A and B, P2 you have C, E, F, and D, and lastly you have a last processor, you have H and G. So under mapping technique, you can broadcastly classify into 2 only, so not similar with others, which is there is a many qualification. So over here you just having two, which is static and dynamic. For static mapping technique, you distribute tasks among processor, and also dynamic mapping technique distribute the work among processor during the executions of algorithm. So scheme for static mapping based on the data partitioning, which is array distribution scheme or also block distribution scheme. So in this distribution, they are d-dimensional, so depend on how much 1D, 2D, 3D. Array is distributed among the processor. So each process receive a contiguous block of array entires along the specific subset of array dimension. So it's depend on how many array dimensions you have. So that is for scheme number 1, and you have another one which is still under the static mapping. You have the block cyclic distribute, and first one is block distribution. So under this one you can try to read the description, but the main point that under the block cyclic distribution is the central idea behind the block is distribution is to partitioning an array into many blocks. So this is the keyword also. Then after that, we will assign the partition to the processor in a round of robin manner. Another one is under randomized block distribution. In this scheme, the array is partitioning into many more blocks than the numbers of available processors. The blocks are uniformly and randomly distributed among the processor. And last one, before you go deeper into a scheme, you have the mapping number 4, mapping based on the task partitioning. A mapping is based on partitioning tasks, depend on the graph, and mapping is not. So this is the keyword, and also naturally expressible in the form of static. So it is not dynamic, but it is static task dependency graph, because we are still under static. And then still under the scheme of dynamic mapping, you can see that there is under centralized scheme and then distribute scheme. Both of this mapping, there is two, which is for centralized dynamic, which is load balance scheme, and another keyword is designed to manage pool of available tasks, but for this one it is dynamic load balance, but this one is centralized, and this one is distribute, still under a load balance scheme. And another keyword is each processor can send a work or receive work from others, and it distribute among processor and exchange tasks at running time to balance the works. So it is all about that for the poster design method. Later on, I will also cover our next topic, next module. So I hope that we can finish it many topic by this week, because we have delay like 1 or 2 weeks behind. So I think only that for this video. Meet again for another video, and have a good day. Bye bye.